The first three problems on the summary are just simplifying, basically ugly fractions. That's what I call them. All we have to do is factor and cancel. So on problem number 1, it needs to be factored, and the factoring would turn out to be the numerator would be the product of 2x plus 3 and x minus 4. So it would be a guess and check factor, but once you go through the process of guess and check, that's what you would get. The denominator is a difference of perfect squares, 4 plus x and 4 minus x. Now at this point we would be looking for factors that could cancel each other, and I don't have the same factor, I have perfect opposites right here. X minus 4 and 4 minus x can reduce each other, but when they reduce each other, since they are perfect opposites, they wind up creating a -1. So I could write the answer as, I'm just going to put that negative sign in front of the 2x plus 3, and I'm going to put the denominator as 4 plus x, and you could put that in parentheses if you want, or you don't have to. It's, your choice. But that's my answer right there. Now the problem also wanted to know excluded values of x. So if I look at my denominators before any of my reducing happened, I find that x cannot equal -4 or +4, because either one of those values would produce a 0 down on the denominator. So moving on to problem number 2, it's pretty much the same thing. My numerator is another guess and check. So this first factor, well, I'm going to put a 5x right here and a 1x right there. And when you go through the process of guess and check, you're going to find 5x plus 2 for this one and x minus 5 on that one. Now this one right here is going to start off with a GCF of x squared. And if you factor out the x squared, you're going to get x squared plus 3x minus 40. Now, that denominator, that part of the denominator right there, is going to be able to be factored down further. So I'm just going to rewrite the numerator. I'm going to put that x squared right there. Now I have a trinomial factor of x squared plus 3x minus 40. That can be factored with an x and an x. I want factors of -40 that add up to +3. So the 8 would be positive, x plus 8, and x minus 5. So now my problem is fully factored. Now it's just a matter of finding your factors that reduce to 1 or cancel. Okay, so x minus 5 and x minus 5. And what you're left with is pretty much the answer right there. 5x plus 2 over x squared times x plus 8. Now, our restricted values or our excluded values. X cannot equal, this would be 0, this would be -8, this would be +5. Now, the last problem in this little first section is problem 3. And all I have is a monomial over another monomial. So really all I have to do is start reducing. I don't have any factoring really. So I can reduce the 42 and the 28. They are both divisible by 7, but they're actually divisible by 14. So that would be a 3. That would be a 2. Now when you have x cubed over x, you're left with x squared up on top. When you have b to the 2nd over b to the 6th, you have b to the 4th down on the bottom, and when you have c over c squared, you have a c on the bottom. And so there are your answers, or there's your answer. But now let's get back to the restricted values of x, or the excluded values of x. Well, there isn't an x. It would just be a and b and c cannot equal 0. Because if any one of those 3 variables equaled 0, then I would have a 0 on the denominator. Okay, for problem 4, we're dividing 2 fractions. So here's the original problem as written right here. I've already gone and written down what the first step would be. The first step would be change division to multiplication and flip the second fraction. So I've already done that. Now it's just a matter of I need to factor and then I need to cancel. So the first fraction, the numerator, x to the 4th minus 16. Now this is a difference of perfect squares as it is right here. So I'm going to say x squared plus 4, and I'm going to say x squared minus 4. But this x squared minus 4 is also a difference of perfect squares, so this part of it can actually go down one level further. So it would be x squared plus 4 times x plus 2 times x minus 2. Now, the denominator down here, it's another guess and check. Okay. So 2x squared would be a 2x right there and an x right there. In order to get 5 in the middle, I would have to put, using a product of factors of 2, so I'm going to put the 2 there and the 1 there, and if I FOILed it out, I would actually get the right thing. So, there's my first fraction, totally factored. Remember, I don't need this anymore, because this became that. Now, my second fraction is also another guess and check because of that leading coefficient. So I'm going to have 2x and I'm going to have x. Okay. Now, in order to get a positive 3 at the end but a negative 7 in the middle, this needs to be a minus 3 and this needs to be a minus 1. And if you go ahead and FOIL it out, I guarantee you'll get that. And then down here on the bottom, I simply need to do a regular trinomial factor, factors of positive 6 that add up to negative 5. So x minus 3 and x minus 2. Now, at this point, the entire problem has been factored. So I just have to look at what can reduce to 1 right now, or what can cancel. So this x minus 3 and that x minus 3. Okay. This x minus 2 right here and that x minus 2 right there. This x plus 2 right there and that x plus 2 right there. So it looks like my final answer is x squared plus 4 times 2x minus 1 all over 2x plus 1. Okay, problem number 5. Problem number 5 begins as a vertical division problem, just kind of as a really ugly fraction. But just like I did on problem 4, I changed division to multiplication, so that means the fraction that was up on top didn't change. But the fraction that was down on the bottom flipped. And this ended up on top, and that ended up on the bottom, and also it changed to a multiplication problem, from a division to a multiplication problem. Now at this point, it's just a matter of factor and cancel again. Just take it one part at a time. The numerator of the first fraction can be factored to x minus 8, x plus 3. The denominator is going to be factored with a GCF of 4, leaving x plus 3. Moving on to the second fraction, the numerator is a difference of perfect squares, 2x plus 3 times 2x minus 3. Now the denominator is a guess and check because of that leading coefficient of 2, so that means this is going to be a 2x and that's going to be an x. And the way it's going to make negative 13 in the middle is I'm going to put my minus 8 right there, but I have to multiply to give me negative 24, so I'm going to put plus 3 right there. And again, if you FOIL it out, you will see that it FOILs out to be 2x squared minus 13x minus 24. That's how you know you're right. Now at this point, since everything's factored, it's just a matter of canceling whatever can reduce to 1. So 2x plus 3, 2x plus 3, gone. This x minus 8 and that x minus 8, gone. This x plus 3 with that x plus 3, gone. So what I'm left with as my answer is a numerator of 2x minus 3 over a denominator of 4. And that would be your answer. In one way, problem 6 could be thought of as being a little bit tougher than 4 and 5 because, in fact, it is a subtraction problem. And when you subtract fractions, you need common denominators. But look what they presented us with. They presented us with common denominators in the first place. So I don't have to get common denominators. I have common denominators. So I already know that the denominator of my answer is going to be 3x squared minus 7x minus 6. The big question is, what's going to be the numerator? Well, I need to subtract my two numerators. So this is going to be 2x squared plus 5x. Now here's the tricky part. That subtraction sign needs to get distributed to all three parts of this trinomial. So it would be minus x squared, and then it would be plus 2x, and then it would be minus 30. So after the first step is done, that's what we've got right now. Now the second step would be combine like terms on the numerator. We're not going to do anything to the denominator yet. So I've got this 2x squared minus that x squared makes a 1x squared. That 5x plus that 2x makes plus 7x. And then as far as my constants are concerned, I really only have this minus 30. So now I'm at the point where all I need to do is factor and then cancel whatever I need to cancel. Now the factoring process on the numerator would simply be your regular old trinomial. Okay? Factors of negative 30 that add up to positive 7 would be x plus 10 and x minus 3. Now down here on the denominator, again we have another guess and check. 3x squared would be 3x and x. Okay. The 6 can either be 1 and 6 or 3 and 2. Okay. My guess is that it's a 3 and a 2. And in order to get a negative 6 but on the end, but a negative 7 in the middle, that would have to be negative and that would have to be positive. So now my problem is in its fully factored form. Now I can just cancel those two x minus 3's, and that's my answer. X plus 10 over 3x plus 2. Problem 7 presents us with a little problem due to the fact that it is an addition problem. So I do need to have common denominators, and right now I don't have common denominators. But they're pretty close to being the same. All it's going to take is one step. The only thing I have to do to turn 2 minus x into x minus 2 is I need to multiply it by a factor of -1. So that's what I'm going to do. I'm going to hit the back half of this problem with a factor of -1. Now what that's going to do is a few things that are going to help us out. It isn't going to do anything to that first fraction. So I still have the first fraction. Now if you move on to that second fraction, it's going to turn the denominator from 2 minus x into x minus 2, but it's also going to change this addition problem to a subtraction problem. So now I'm there. I have common denominators, so I know the denominator of my answer is going to be x minus 2. But what's going to be the numerator? Okay, it's going to be x plus 3 minus x. But remember that minus sign gets distributed over here too, so it's a minus 5. So x minus 2 is definitely my denominator. This x plus that negative x cancels each other out, and 3 minus 5 is simply -2. So that's the answer to that problem. Problem number 8 presents itself as a subtraction problem, a simplify. It's not a solve. There isn't an equal sign here. So we're going to have to keep this in fraction form. We're going to have to find the common denominator, and we're going to have to use the common denominator. Now, this really isn't that difficult because each denominator is its own distinct binomial. So first thing I'm going to do is I'm going to change it from a subtraction to an addition problem by making that a plus and turning the 2 into the -2. It's going to help in about a minute or so. Now, as I said, each denominator is a distinct binomial. So that almost makes it a little bit easier because what we know is the common denominator is going to be the product of x minus 3 and x plus 1. Now, the numerators have to be adjusted to include what they did not have. So this numerator that started off as x, it already had the x minus 3, so it needs x plus 1. This fraction that already started off with x plus 1 on the denominator, it doesn't need another x plus 1, it already has it, but it does need the x minus 3. So now I'm at the point where I have common denominators. I know what my denominator is going to be. It's going to be x minus 3 times x plus 1. Well, what's my numerator going to be? Well, I can't figure that out until I expand all this and combine my like terms. So this is going to be x squared plus x. Okay. Now, this is why I changed the plus to a negative, because I'm really distributing a -2. So that would be plus -2x, and that would be plus 6. So I'm going to continue with my denominator, x minus 3 times x plus 1, and now I'm just going to simplify my numerator. I don't have any other x squared, so I would have an x squared, a positive x, and then plus a -2x would be a negative x minus x, and then plus 6. Now at this point, if I could factor the top, I would. I would factor it and then see if anything cancels. But I can't. This is not a factorable trinomial, so at this point I'm done with that problem. As you can see by the instructions for 9 through 12, not only are we supposed to solve for x, but we're also supposed to identify, how many solutions there are. So on problem number 9, I'm just going to cross multiply because it's fraction equals fraction. So, and it doesn't really matter which way I start. I'm going to start that way. So x times 2x is 2x squared equals, and when I go that way, 1 times x plus 1 is simply x plus 1. So that's going to be the start of my answer. But it is a quadratic, so I want to set it equal to 0. My 2x squared is positive, and that's the way I like it. So I'm going to bring the x plus 1 over to the left-hand side. So the 2x squared stays. This becomes minus x. This becomes minus 1 equals 0. Okay, now I'm going to factor this problem. And it's a guess and check factor, so 2x and x. Okay, the factors of 1, there's really only one combination that's going to get you 1, and that's 1 times 1. But where does the positive and where does the negative go? The negative's going to have to go here, and the positive's going to have to go there in order to get negative x in the middle. So now that I have the problem fully factored, now I need to take it to the next step, which would be the solutions. So this one would be x equals 1, because 1 minus 1 would be 0. Now on this one it might not be so obvious, or at least it wasn't to some of my students, so I'm going to set the factor equal to 0, 2x plus 1 equals 0, and then I'm just going to do the steps that it takes to solve. So 2x equals negative 1, move the 1 to the other side, and then divide both sides by 2, and you would get x equals negative 1/2. And so that would be my 2 answers. And sure, there are 2 answers. I'd make sure that neither one of these are restricted answers or extraneous solutions, which they are not. So the answer over here is there are 2 real solutions. Now moving on to problem number 10, a similar problem. I've got a fraction on the left and I've got a fraction on the right. So I'm just going to do my cross multiplication again, and again it doesn't matter which way you go first, so I'm going to go this way first. Now remember, that 7 needs to get multiplied by the 7 and the x. It's as if the 7 plus x had parentheses around it, because you are distributing. So this would be 49 plus 7x equals, now negative 1 times x squared minus 7x is negative x squared plus 7x. Now, I notice my negative x squared, I got my x squared negative and it's over here. So what I'm going to do is I'm going to move everything on the right over to the left, because I want that x squared to be positive. So I would add an x squared and I would add an x squared right there. I would subtract a 7x, but I'm going to subtract it right underneath that one. So actually, I'm going to end up losing all my x's to the first power. So I've got x squared plus 49 equals 0. Now I'm going to solve for x. This isn't factorable, but I can solve it by algebra. I'm going to move the 49 back over to the other side. I'd have x squared equals negative 49. And now I would take the square root of both sides, and I would be left with x equals plus and minus. Now since I'm taking the square root of negative 49, okay, it would be an imaginary number. It would actually be plus and minus 7i. So that would be the answer, or actually the answers to problem number 10. There would be 2 answers, but they aren't real, they're imaginary. So I would circle up here, no real solution. Problem number 11 is definitely one of the most involved problems on the summary notes. We have a equation that needs to be solved so the good part about this problem is the idea is to eliminate the denominators altogether. But you have to know, what do I have to use to get the denominators to all go away? Well, the answer is the least common multiple. So what I'm going to do on this problem is I am going to multiply the entire problem by the least common multiple of x times x minus 5 times x plus 5. Now, I had to put it over here on the right because I didn't have enough room over here on the left, but it's the same as if it was over here on the left. This whole thing needs to get distributed to each part of this problem. That's why I put the original problem in brackets. Now, one by one, we're going to look at what cancels and what remains. So on this first fraction, I've got the numerator of 5, but this denominator of x minus 5 cancels with that x minus 5, so that first fraction that has a 5 in it needs to get multiplied by x times x plus 5. Now, moving on to the next one. The x plus 5 that's down here cancels with the x plus 5 that's right here. So that negative 3 needs to get multiplied by x times x minus 5. So, negative 3 times x minus 5 equals. Now, when we move on to this third fraction, the equals fraction, it's this x right here that cancels with that x right there. So the 2 needs to get multiplied by x minus 5 and x plus 5. So we've done all the hard work at this point. We've eliminated the denominators. We've gotten rid of the fractions. Now the next thing is just working out this mess right here. Now this 5 times x can be thought of as 5x times x plus 5. So that would be 5x squared plus 25x. This minus 3x can be thought of as a negative 3x, but it needs to get multiplied by the x minus 5. So that would be negative 3x squared minus 3x squared, and then it would be plus 15x. Now, this 2 needs to get multiplied by x minus 5x plus 5. Well, x minus 5 times x plus 5 is x squared minus 25. So now I have 2x squared minus 50. So I've cleaned it up a little bit, but I'm going to clean it up some more. I'm going to move everything over here on the left to the right. So this negative 2x squared is going to go right under that negative 2x squared. This plus 50, I don't have any other constants over here, so I'm just going to have to add a plus 50. Now, what that's done is it's totally cleared out my right-hand side. My right-hand side is now 0. But let's combine like terms. I've got this 5x squared minus 3x squared would be 2x squared, but I have to subtract that 2x squared also, and so all my x squareds are now gone. Now I've got 25x plus 15x, which is 40x, and then remember that constant I brought over is just plus 50. It didn't have any other constant to go with it. So now I'm at this point. 40x plus 50 equals 0. So I'm going to bring the 50 over here. Now I've lost my x squareds, so I'm just going to solve this problem using multiple step algebra. My 50 is now over here, so now it's a negative 50. Now I'm going to divide both sides by 40, and so my x is simply going to equal negative 5/4. Now, we have to categorize our answer. What did we get? We got one real solution. And that's your answer to problem number 11. Okay, I've already started problem number 12, as you can see, by factoring each denominator. Now, the reason I needed to factor each denominator on this one is because I needed to know what the denominators were made up of. So on this first fraction, the denominator is made up of x times x minus 1. I factored out the greatest common factor of x. Now, on the second one, it's just x minus 1. But now I know, I can see that in order to clear all the denominators, I need to multiply this entire term by x times x minus 1. So I'm doing something very similar to what I did in the last problem. I'm backwards distributing. It needs to go there, and it needs to go there, and it needs to go there. So by taking each fraction one by one, okay, this first fraction, it has everything. So everything cancels. That x cancels, that x cancels with that x. The x minus 1 cancels with that x minus 1. So the first fraction really didn't need anything because it had everything. So it just canceled. Okay, now moving on to the second fraction. The second fraction had the x minus 1 already, so those cancel. So that second fraction, when the fraction goes away, it becomes minus 2x. So minus 2x. Now, for the third component in this problem, the equals to, it wasn't in fraction form. It didn't have a denominator other than the denominator was 1. So there's nothing that can cancel because there was nothing there in the first place. So 1 times x minus 1 is simply x squared minus x. So that's where I am now after all the denominators have gone away. I still have a quadratic, so I'm going to put the minus 2. I'm going to move the 2 over there. I'm going to add the 2x, so I'm going to put the 2x right there. And what I'm left with is the trinomial 0 equals x squared plus x minus 2. Now, I need to factor this. I'll keep the 0 right there. Okay. The factors of negative 2 that add up to positive 1 would be x plus 2 and x minus 1. Which means my solutions would be x equals negative 2 and x equals positive 1. But remember what we have to do. We have to check for extraneous solutions. If we go all the way back up to the beginning of the problem in its factored form, I notice that x cannot equal 0 or positive 1. Well, I just got an answer of x equals 1 right there. So what I have to do is I have to cross that out as an extraneous solution. So there really aren't two answers to this problem. There's only one real solution because the other one was extraneous. Okay, problem 13 is one of those average cost problems. We start off with the bus trip. The bus is going to cost $120. Okay, and originally there were X number of people who had signed up for it. So 120 people, X number of people were going to split $120. That would be the average cost for each person. But something happened. 6 people decided not to go on the trip. So the new amount of people on the trip is going to be X minus 6. Okay. Now, what did that do to the average cost of everybody who's remaining? Well, if 6 people back out of the trip, then that's going to increase the cost for everybody else, and in this problem, it said it increased the cost of everybody else by $1. So here's the setup. The original average cost, okay, but then $1 was added to everybody because 6 people left, okay, or 6 people backed out of the trip. So now I'm at this equation right here. Okay. Now, the key to the equation, just like the key to all the equations, is to get the denominator to clear out by multiplying by the least common multiple. So, that least common multiple would be X times X minus 6. Okay. So, I'm going to distribute X times X minus 6 to all 3 parts of this problem. Now the first part already had a denominator of X, so that X and that X are going to cancel each other, and all I'm left with is 120 times X minus 6. Now if we look at the second term in this problem, there isn't a fraction. It doesn't have anything to cancel down here because there isn't anything down here other than a 1. So I need to take 1 times X minus 6, which is X squared minus 6X. Now for this fraction right here, the denominator was X minus 6, so the denominator of X minus 6 is going to cancel with that X minus 6, and it's going to be left with a 120X. So now I've cleaned up the problem a lot by clearing out the denominators. So I'm going to distribute this 120X minus 720 plus X squared minus 6X equals 120X. Now, I can do quite a few things at this point, but I'm going to cancel this 120X with that 120X. And I'm left with, what that's done is, I'm left with a 0 on the right-hand side, which is what I want because this is a quadratic. X squared minus 6X minus 720 equals 0. Now, this is factorable. You know, all the problems like this are going to be factorable. Now, you might have to play around with this combination for a minute. We're looking for factors of negative 720, multiples of negative 720 that have a sum of negative 6. Okay? And they do exist, I guarantee you. It's a combination of 30 and 24. But in order to make the negatives work right, it's got to be negative 30 and positive 24. Which means the factors in the problem are X minus 30 and X plus 24 equals 0. So those are the factors. Now I need the solutions. The solutions are X equals 30, that's one solution, and the other one is X equals negative 24. Now you have to remember what X represented in the first place. X represented the original number of people who had signed up for the bus trip. Well, you can't have negative 24 people. So that answer gets thrown out as an extraneous solution just because it doesn't make sense. X needs to represent people. So the answer to the question is, how many people originally signed up for the bus trip? The answer is 30. Okay, so for problem number 14, I'm going to show problem 14 a couple of different ways because different teachers taught this problem different ways. I'll start off with the way that I taught it, and this is a work together problem to get the job done. Now we know Johnny can do the job in 5 hours, so his rate is T over 5. T meaning time. And Megan can do the exact same job in 4.2 hours, so her rate is T over 4.2. Now the problem says if they were working together, and that's why the addition sign, if they were working together, how long would it take for them to get the job done? And in this problem, the 1 represents the job is completed. So, at this point in time, we still have another equation where the fractions need to get eliminated. And it might not be the most obvious thing right here, but what number would clear the fractions? Okay. Well, all you got to do is figure out what is 5 times 4.2. So over here, just grab your calculator. 5 times 4.2 is 21. So 21's the magic number. I'm going to multiply every single part of this problem by 21. And the fractions are going to go away, and it's going to turn into a simple algebra problem. Okay? So this would be 21t over 5 plus 21t over 4.2 equals 21 times 1, which is 21. Now, what is 21t over 5? Well, 21 divided by 5 is 4.2. So this would be 4.2t. Okay. 21t divided by 4.2 is 5. 21 divided by 4.2 is 5. And 21 times 1 is simply 21. So I have a pretty simple algebra equation at this point. 4.2t plus 5 is 9.2t equals 21. So I'm going to divide both sides by 9.2, so t would equal 21 over 9.2, which is approximately, because I think we go to the tenths, 21 divided by 9.2. We're going to call it approximately 2.3 hours. So t is approximately 2.3 hours. That's what it's going to take to get them done, to get the job done if they work together. Now, I said I was going to do this a couple of different ways. Okay? We have some teachers who have the problem set up like this. They take the rate of Johnny, which is if he can do the job in 5 hours, then he gets 1/5 of the job done each hour. And then when we add in Megan, her rate is 1 over 4.2, and the equal sign is 1 over t. So that's the way some of the other teachers set up the problem. Now you'll see what happens. I'm still going to multiply each part of this problem by 21t. because 21 is 5 times 4.2. It's the least common multiple of 5 and 4.2. Now, when I do my backwards distribution, okay, 21t divided by 5 still gets you back to 4.2t. 21t divided by 4.2 is 5t. Okay. Now this one, 21t over t, the t's are going to cancel, and we're left with 21. So I'm back at this spot again. This is now 9.2t equals 21. Same spot I was at right there. So t equals 21 over 9.2, okay, which, as we know, is approximately 2.3 hours. So you get the same answer. The setup is a little bit different, but after you get a couple of steps into the problem, it's all the same anyway. Okay, so problem number 15 is a comprehensive rational function problem. A lot of the answers are going to be based on the graph, but some of them are actually algebraic answers. But like I said, they're based on the graph, so the first thing we should probably do on this problem is graph it. So, the function is 1 over x plus 3 plus 2. The first thing we're going to do is we're going to move the asymptotes. The vertical asymptote is going to be a shift of 3 units to the left. So the x plus 3 results in a 3 units to the left shift. So there's my vertical asymptote right there. Okay, and I can always just identify it too. That is an equation of x equals negative 3. Now the horizontal asymptote is a shift of up 2. So I'm going to take that horizontal asymptote and I'm going to shift it up 2. And there's my horizontal asymptote. And that has an equation of y equals 2. Now I've actually answered a couple of questions over here already. What is the equation of the vertical asymptote? X equals negative 3. What's the equation of the horizontal asymptote? Y equals positive 2. Okay. Now, because this is a 1 right up here on top of the fraction, all it means is I'm going to go over 1, up 1, and make that point. That's my key point. That's one of my key points. And then the graph does something like that, because remember, it never touches the asymptotes. It just gets closer and closer. Now on this one, it's going to go over 1 down, and it's going to do something like that. Okay? All right, now, first of all, what's the x-intercept? Does it have an x-intercept? Yes, it does. It is right here. Okay? Here's where the graph crosses the x-axis at that point. Well, we need to figure out what it is. Okay? So, x-intercept. Set y equal to 0. So, I'm going to set the function equal to 0. 0 equals 1 over x plus 3 plus 2. And now I just need to solve this. The easiest thing to do would be move the 2 over to the other side. Negative 2 equals 1 over x plus 3. And now just cross multiply to get my answer. You could throw a 1 under that negative 2 if you want. And when you cross multiply, one way, 1 times 1 is 1. When you cross multiply the other way, you get negative 2x minus 6. So I'm going to add 6, add 6. So now I've got 7 equals negative 2x. I'm going to divide both sides by negative 2. And I'm going to get x equals negative 3 1/2. And that is going to be my x-intercept. X equals negative 3 1/2. That's that point right there. Okay. Now, the next question is, how about the y-intercept? Does it even have a y-intercept? And sure it does, right here. Okay. Here's the y-axis, and here's where the graph crosses the y-axis. So, we're going to find what the y-intercept is. So, y-intercept. Okay. Set x equal to 0. So, go back to the equation. And wherever there's an x, put a 0 in it. Y equals 1 over, now 0 plus 3 would be 3. So 1 over 3 plus 2. So there's your answer right there. Y equals 1/3 plus 2, which is 2 1/3. So your y-intercept, okay, is at 2 1/3. Now, identify where the function is increasing. It never increases. It decreases in this section, and then once it jumps up here, it continues to decrease in that section. So, the answer is it never decreases. Or, I'm sorry, it never increases. Okay? It's always decreasing. So really, in one respect, you could say, well, it's negative infinity to positive infinity because it's decreasing all the time, except there's something in the way. There's that asymptote of negative 3. So you have to write it in two different sections. Negative infinity to negative 3, and from negative 3 to positive infinity. That's where it's decreasing. Okay. Now, where is the function greater than 0? Okay. Well, in this part of it, it's from negative infinity to that point. So negative infinity to the place where it hits the x-axis, and that's otherwise known as the x-intercept. And then in this part of the graph, it's above 0 all the time. So negative 3 to positive infinity. Now, where is it below 0? There's a tiny little part of this graph that is below 0. It's the part that begins at the x-intercept, negative 3 1/2, and ends at the asymptote, negative 3. Okay, for problem number 16, we have a composition going on. H of x equals f of g of x. Now, we've done this a few times before in other units, but really all this is saying work from the inside out. Plug g of x into f of x. Well, here's g of x right here, the x minus 4, and if I'm going to plug it into the f of x function, there's only one place that it can possibly go, and that is right there. So my h of x function is now going to be 3 over x minus 4, because really all I did was I did substitution. X minus 4 went in x's place. And then I'm going to do a minus 5. So they really don't want us to do much more with this other than identify the vertical and the horizontal asymptotes. Now the x minus 4 means there's going to be a vertical shift of 4 units. So that would make this vertical asymptote x equals positive 4. Now the minus 5 at the end of the equation means there's going to be a shift of down 5 on the horizontal axis. So this is going to be y equals negative 5. So my horizontal asymptote, x equals 4. My vertical asymptote, y equals negative 5. Okay, for problem number 17, we're going to do a graphing solution and an algebraic solution. The bottom line of this problem says we want to know where f of x and g of x equal each other. Well, they tell us what the two equations are, so I'm just going to set the two equations equal to each other. F of x is 3 over x minus 2 plus 1. Okay, that's f of x, and we're told that it equals g of x, which is negative 1. So the algebraic setup right here would be like this. Now again, there's a couple ways to go on this, but the easiest thing to do would be move the plus 1 over here with a minus 1, and you'd be left with 3 over x minus 2 equals negative 2. Now the reason that was the easiest way of doing it is now I just have a cross multiplication. I'm going to throw a 1 underneath that negative 2. When I multiply this way, 3 times 1 is 3. When I multiply the other way, I get negative 2x and then plus 4. So I have a simple little algebra problem right now. I'm going to subtract 4. I'm going to subtract 4. So I've got negative 1 equals negative 2x. I'm going to divide both sides by negative 2. And I have 1/2, positive 1/2 equals x. Okay, so x equals 1/2. That's the algebraic solution. Okay, now what is the graphic solution? Okay, well, I just found my x value as being 1/2. So what's my y value of the algebraic solution? Well, I'm told right here that the two functions are equal to each other, and one of the functions has a value of negative 1, so that means the other one must also be equal to negative 1. So there's my graphic solution right there. Okay? Where my two graphs come together should be at 1/2, negative 1. Now, let's try to make sure they do that. Let's graph f of x first with a black pen. And so I'm going to have to shift my asymptotes 2 to the right. And up 1. So there's, well, not yet. Those are my asymptotes. Okay. Now we'll worry about, because there's a 3 up there, I'm not just going to go 1 over 1 down, but now the g of x function, g of x equals negative 1. I'm going to put that in a red pen. G of x equals negative 1 is a constant. It's not an asymptote, so I'm not going to do it with a broken line. I'm going to do it with a solid line. So there's g of x equals negative 1. Now we know where they come together is at 1/2, negative 1. Okay. So when x equals 1/2 and y equals negative 1, it's about right here. So that means this must do something like that. Because remember, you can't cross an asymptote. So this part has to stay within this region, okay? And that means the other part, I'm really not going to take a whole lot of care to see where that other point is, but I would suspect that it's, let's see, where would it be? 1, 2, 1, 10. I don't know, I suspect it would be somewhere about right here. So there's your graphic solution, and there's your, here's your graphic solution right here, where the rational function graph and the constant meet each other. Okay, this brings us to our last two problems of the summary notes. Problem number 18 is another ugly fractional problem, but because it's an equation, we are going to ultimately remove the denominators from the equation. So the way we're going to do that is we're going to multiply all the terms in the equation by what would be the common denominator of x times y times z. So again, one more time, it would be the backwards distribution. Every single term is going to get multiplied by x, y, z. So on the first term, it's going to be the x's that cancel. So it would be 2yz equals. On the middle term, it would be the y's that cancel. So it would be 5xz. And on that last term, it would be the z's that cancel. So it would be minus 3xy. Now, we're trying to solve for z. So these are not like terms, but they both have z in them. So I'm going to move the 5xz over to the other side to where it joins the 2yz. And you'll see why in a minute. Now, the reason I did that is so I can factor out a z. Two different terms that have z in it isn't going to help me with what I need, but I can factor a z out of those two terms as the greatest common factor, and I'm left with 2y minus 5x equals negative 3xy. And now I really only have one more step, because remember, the idea was to solve for z. I need the equation to start with z equals. Well, I can do that if I divide both sides by the binomial 2y minus 5x. And that's what I would end up with, an equation that says z equals negative 3xy over 2y minus 5x. And so that would be the answer to this problem. Now, problem number 19, we have a complex fraction, fractions within fractions, and again, the idea is going to be clean this whole thing up by removing these denominators right here. So, two of the denominators are x, one of them's 5, so the key is multiply every single term in this problem by the common denominator of 5x. And when you do, I promise you it's going to clean up. So, when 5x gets multiplied by 4 over x, the x's are going to cancel and you're going to be left with 20. When 5x gets multiplied by x, that makes 5x squared over 5, so the 5's are going to cancel, and we're going to be left with x squared. Now, when the 5x gets multiplied by 2, there's nothing that cancels, so it's simply 5x times 2, which is 10x. And then when the 5x gets multiplied by the 3, that makes 15x, but it's over x, so the x's are going to cancel, so we've got 15. So, that's actually going to be our answer, but what we would do is we would try to factor, if any of these are factorable, we would factor it to see if anything cancels. But the top, the numerator of this right here, that's not factorable, so I'm going to leave it as 20 minus x squared. Now the denominator down here, I can factor out a GCF of 5, so I'm going to. I'm going to factor out a 5, and I'm going to be left with 2x plus 3. Now, did that really help me? Not really, because there isn't anything that's going to reduce with that 5, and there isn't anything that's going to reduce with that 2x plus 3. But it is, the final answer is now in factored form. So that's it. That's the end of the summary notes.